In this video, we'll cover complex ion and coordination compound. Here you see a table that shows the definition of three different definitions of acid and base. My focus will be on the Lewis acid and base. Lewis acid and base, by definition, says if it's an acid, then it is an electron acceptor. So BF3 over here, you see that the lone pair of the water has been accepted by the acid, so hence this is the acid. Whereas a base would be the electron donor, and you see that the water is donating its electron pair from the oxygen to the boron. So therefore, because it's a donor of the electrons, it's considered to be the Lewis base. We can take this particular definition and apply it to transition metal, and here is how. So here is a reaction where you have ammonia plus the silver. Silver is the transition metal. The silver then forms a bond with ammonia by the ammonia sharing its donating its electron to silver, and silver accepting that electron. Now there is now an equal sharing of electrons. So silver, we can say that this is a transition metal that's acting as a Lewis acid because it's accepting the electrons. Whereas the ammonia will donate its electrons, so we can consider that the ammonia is a base, Lewis base, because it can attach to the metal by donating its electrons. On the right-hand side, you have silver and 2 ammonia that is being attached. The attached ammonia that act as a base are considered to be a ligand. This entire structure with a positive charge in the end is considered to be a complex ion because it's charged. Ion because it's charged. The bracket represents that anything that's inside here are covalently bonded. But anything that goes outside of the bracket, that is not covalently bonded. And we don't see anything outside right now, so we could ignore that. But again, bracket just refers to anything that is inside are bonded with each other via covalent bonding. Here's another example. We have 6 ammonia added with cobalt, and then it forms into this complex ion with the positive 3 charge. So again, the cobalt has accepted electrons, so it would be the Lewis acid. And the ammonia is a Lewis base because it donated the lone pair from the nitrogen to form a covalent bond with cobalt. And there's 6 of them. The individual NH3 here that has been bonded are considered to be ligands. And the entirety, this whole entire structure with 3 positive is the complex ion. Let's say I were to want to try to neutralize this complex ion by adding in 3 chlorine. The 3 chlorine will neutralize the 3 positive, and now it forms, it adds on together, and now this is considered to be a counter ion. Counter ion is outside of the bracket, so you can see that it's outside of the bracket over here, it's outside of the bracket over here, meaning that they're not participating in any sharing of the electron or covalent bonding. This neutral compound is no longer called a complex ion, but now a coordination compound because it is neutral. The +3 is canceled out by the -3 individual of -1 for each chlorine counter ion. Here are some common bases that can exist as a ligand when bonded to a transition metal. So we can have water added with chromium. We can have ammonia, which we've seen just previous slide, fluoride ion, chloride ions, and so on and so forth. You see cyanide, thiocyanate, and nitrate. These are also potential as well, but also note I wrote or. It means that the lone pair as an acid can be donated from the carbon and the nitrogen or the other one. So it could sort of depends on which one is going to end up donating to the acid. So these are all potential ligands, and this is also located in your reference sheet. Let's do a learning check. Determine if the following are coordination compounds, complex ions, and identify the transition metal, counterions, and ligands. So over here, if it's a neutral, we can automatically say that's a coordination compound. So here's my coordination compound. The next one over is a charged, has a bracket and 2 plus, so it's charged, so this is a complex ion. Let's identify the transition metal here, which is just cobalt. That's a transition metal. What about counter ion? There is chlorine, right? That's your chlorine right here, and there's 3 right there, should be Cl minus. And then we have what's our ligand? Our ligand is NH3. And there's 6 of them. You can note that there's 6 of them. So let's do for the complex ion. What about transition metal here? The transition metal here is P. That's platinum, and then we have our and then we want to identify counter ion. Well, there's nothing on the outside of the bracket, so there's no counter ion. So we'll just write no counter ions. And then it says, what are the ligands, right? So ligand would be things that are attached to that platinum. And there's 2. There's NH3 and the Cl. So NH3 and Cl are the ligands. All right, so what I want you to do is go ahead and try the next 2, C and D, and then come back and check the key. And here's the key. In this complex ion and coordination compound exists a coordination number. So what is this number? It just shows the number of the donor atoms bonded to the central transition metal. So all you do is really look at the transition metal that's inside and see how many are bonded to that cobalt. So here's 1, 2, 3, 4, 5, 6. And so the coordination number is 6 here. Coordination number for here, silver, there's only 1 and 2. So the coordination number for these guys are just 2. So hopefully that's a little easy. Now let's do a learning check. Write out the chemical formula based on the structure given, then determine the coordination number. So let's give this a try. So we have our platinum, and we have chlorine around it. So we always write the transition metal first, which is platinum. Then we write chlorine and determine how many are around it. So there are 6 around it. And then we're going to bracket this out, and then notice that there is potassium outside, and there's 2 of them. Because that this is a neutral compound in totality, we don't write the plus and the negative. Okay. Oh, one more thing. We need to indicate there's 2 potassium, so you need to write 2 right there. Okay. Now it asks for the coordination number, and you can see there are 6. Okay, 6 of the chlorine, so coordination is 6. If you didn't see, coordination number is 6. Now, it's that you didn't see this image and you're just given this. How do you find the coordination number? Well, you can sort of look at the subscript over here and see what's being attached to the platinum. You can already tell there's going to be 6. What about for this one, zinc? So we have our zinc. We write that one first. And the ligands are C, N, and N. And how many of that? Well, there are together total, CN and N, carbon, nitrogen, there are 4 of them. So we write in brackets because to note that all of these are bonded to the zinc. And because there is no counter ion, we just write the 2 minus charge. The coordination number for this one would be 4. So try for the next one and come back. And here is a key.